Hello, and welcome to another session of Stop, Look, Listen, and Learn. In today's session, we're going to be talking about how to compute the present value and the future value of an immediate annuity. So let's jump right in. So I'm starting a series on annuities here, and so there are basically two types of annuities. There is an immediate annuity and a deferred annuity. An immediate annuity is one that starts right away, and a deferred annuity is one that starts after a period of time, right? And you typically encounter deferred annuities when you retire or prior to retiring, you invest money in an annuity, and the annuity doesn't start until 10, maybe 15 years down the road after you retire, right? But in today's video, we'll be talking about immediate annuities, and those are the ones that start right away. And there are basically two types of immediate annuities. There's what we refer to as an ordinary annuity. That is where each of the payments is made at the end of the period, and then there are what we refer to as annuities due, and that's where the payments are made at the beginning of the period. And then you can also have annuities where the payments are level, and you can also have annuities where the payments are either increasing or decreasing. So in this video, as you can see from the check mark here, we're going to be talking about immediate annuities that have level payments and that are of the ordinary type, meaning that the payments are being made at the end of the period. And then I'll have subsequent videos where I talk about how to find the present and future values of an annuity due, and that's where the payments are made at the beginning of the period. And then I also have some videos on how we find the present value and the future value of annuities where the payments are either geometrically increasing or geometrically decreasing. So let's get started by looking at a simple example here. So you have a basic fact pattern where you have an investor who is going to be receiving, say, $1,000 at the end of each of the next 5 years. And we're going to assume, for purposes of this exercise, that the effective annual rate is going to be 6%. And so then the question becomes, what is the present value or the value today at time zero of that stream of payments? So let's look at how we can visually depict this. And this is also a good exercise whenever you get a problem like this, is to draw a timeline just so you make certain that you're able to capture everything. So in this case, the investor is going to be receiving $1,000 at the end of each of the next 5 years. So let's draw this out on the timeline here. So we start off at time 0 here. Let's say this is time 1, time 2, time 3, time 4, and make the line a little bit longer, and then say time 5. And so, and this is time here in years. And so at the end of the first year, the investor will receive $1,000. And at the end of the second year, we'll receive 1,000, 1,000, 1,000, and 1,000. So that's the stream of payments that this investor will receive. And then we're also assuming that the effective annual rate is 6%. And the discount factor, which we'll denote as V here, is going to be equal to 1 over 1.06. And that's what we're going to use as the discount factor. So what I want to do is I want to use first principles to value the stream of payments, and then I want to walk you through the formula that you need to learn and commit to memory and become very proficient at using. So I like to refer to this as the VEP, value each payment. And this is the most fundamental way to do it, and it's the way to do it when you want to make certain that you are getting the correct answer. So basically, the first payment will need to be discounted back for 1 year, and so that's going to be 1,000, and we're going to say times V to the first power because we're discounting it back 1 period, right? And then the second payment will likewise need to be discounted back to time 0. So we'll have 1,000, and this time it's going to be multiplied times v raised to the second power, because we're going back 2 periods. And then in a similar fashion, we'll discount the payment that we receive at the end of year 3, discount that back for 3 periods, and then the payment at the end of 4 periods, we'll discount that back for 4 periods, and then finally the last payment, we'll discount that back for 5 periods, right? And then if we sum all of this, then this is going to give us the present value of this ordinary annuity, right? So if you get your calculator out, essentially what you're going to do is discount each one of these payments here and then sum up all of the discounted values. And one of the things you need to be able to do is to work very quickly on the exam, because you'll be under time pressure. So using this BA2 Plus calculator, what I would recommend doing is, so I would say 1.06 and then take the inverse of that, which is 0.94339623, and then I would just store that in the 0 register. And the reason I would do that is because we're going to be using that number a number of times here, right? And then, so that number raised to the first power is going to be itself, and then we multiply that times 1,000, and then we get the present value of that first payment, and then I would store that into the first register, and then I would recall V again, and then this time I would hit the X squared button to figure out what that value is squared, and then multiply that times 1,000, and then I would take that number and store that into the second registry, then recall V again, and then this time I would raise that to the third power, and then multiply that times the third payment, and then store that one into register number 3, and recall it again and raise it to the fourth power, and then multiply that times the payment in the fourth period and store that in register number 4, and then finally recall it again, raise it to the fifth power, and then multiply that times the fifth payment of 1,000, and then store that into the fifth registry. And then what you want to do is recall the numbers in the first registry, second, third, fourth, and fifth, and sum them. So recall 1, and then plus recall 2, plus recall 3, plus recall 4, plus recall 5, and then that's going to give us an amount that's equal to $4,212 and basically 36 cents, right? And so that would be the present value of this annuity here, which is just going to be the sum of each of the payments that this investor is going to receive, right? Now, here we only have 5 payments, which I think is a sufficient number of payments to illustrate how you do this, but on the exam you might have an investor who's going to be getting 25 or 30 payments, so you're not going to be able to add all these up individually like we just did here, right? So you're going to have to rely on the formula or to use your calculator TVM roll here. But let's look at the formula here so you know what that is, and it will save you some time, and also I'll show you how to compute this on the calculator as well. So the formula that we're going to have is going to be, the present value is going to be equal to 1 minus V to the N, and that's going to be all over I, written as a decimal, or 0.6%, or 6%, which is going to be written as 0.06. So that's how you would write it. Now, keep in mind that V here is going to be a number that ranges, or that's going to be a number that's between 0 and 1. And when you raise that, a number between 0 and 1, when you raise it to higher and higher powers, that number is going to get smaller and smaller, right? So if we just plug in what we know here into this formula, so we would have the present value is equal to 1 minus 1 upon 106 raised to 5. N is 5 because we have 5 payments. And then we're going to divide all of that by 0.06 because that's the effective annual rate that we're using to value the annuity here. So now if we go back to this and we can basically recall what's in the 0 registry, which is V, and then we raise that to the 5th power to figure out what that is, and then we make that a negative, and then we add 1, and we get that difference there, and then we're going to divide that by 0.06, and then we get that annuity, present value annuity factor, and then we're going to multiply this whole thing here by 1,000 because that's the amount of the payments. And when you do that, you get the same thing. You get $4,212.36, right? And so you can see by using this formula here, if you know the payment, I'll just put this here as payment, and you know what the annual effective interest rate is, and then you know the number of payments that you're going to receive, then you can very easily compute the present value of an ordinary immediate annuity where you have level payments here, right? Now, one thing I'll talk about a little bit later, but I want to mention it now, is when we talk about that annual effective interest rate, that needs to be the annual effective interest rate for the period that matches the frequency of the payments. So here we're receiving these payments every year, so I is the annual effective interest rate. If we were receiving these payments every month, then we would need the monthly effective rate. The periodic effective rate needs to match the frequency of the payments, right? So just keep that in mind. So that's essentially how you would do that. You can add up each of the payments individually and sum the present values to arrive at the present value of an ordinary immediate annuity, or you can use this formula here and drop those numbers in and get the same present value of an immediate ordinary annuity. And then you can also do this on your TVM roll as well. So let me just clear out of here, hit second, clear TVM. Just make certain that everything is cleared out here. And so what we would do here in this case, there's going to be 5 payments, and so we get 5 is equal to N. The annual effective interest rate is 6, so that's what IY is going to be. We put it in as 6 and not as a decimal. And we don't know what the present value is, that's what we're trying to find, but we do know that the payment each year is going to be 1,000, so that we would put 1,000 as the payment. And then if we hit compute present value, we get the same number. We get $4,212.36, and it comes out as a negative amount here, and that's because if we're viewing it from the perspective of the investor, then the investor will have to invest $4,212.36, which would be an outflow. And as a result of making that investment or outflow, he or she will receive each year $1,000 at the end of each year. And so that's why it shows up as a negative on the calculator, right? So that's the other way to do it. And on the exam, that's probably the way that you would want to do it, because you can save a lot of time just by putting in those numbers. But I like to go through this just so you have a good understanding of what is actually going on, and you understand how those formulas work, so that if you're ever in a situation where you can't use a TVM roll, you know how to compute the present value of an ordinary immediate annuity, right? So now that we have the present value, let's look at how we can compute the future value of an ordinary immediate annuity. So here, let's look at the basic fact pattern. So now we say an investor is going to be depositing $1,000 into an account, and he or she is going to do that at the end of each of the next 5 years. And again, we're assuming that the annual effective interest rate is going to be 6%. So the question becomes, what will be the future value of that account at the end of the 5th year? In other words, what would be the future value of that annuity? So let's look at how we would do that. So same thing here. So draw out the timeline. That's always, helpful. Minimizes the likelihood of making mistakes. So here we got time 0, got 1 year, 2 years, 3 years, 4 years, and then of course 5 years, and then putting in $1,000 at the end of each year, end of the 2nd year, end of the 3rd year, end of the 4th year, and then the end of the 5th year. And so let me just make a note here. So I equals 0.06, and N equals 5, because we have 5 payments here, right? So this first, so let's go in reverse order. So at the end of the 5th year, he's going to put $1,000 into the account. So the present value of that account, or future value of that account, is just going to be the $1,000. So if you put $1,000 in the account today, the value of it is $1,000. So we'll just write $1,000 here. And then the one at the end of the 4th year, when he deposits that money, then that's going to grow or accumulate for 1 year. And so we need to accumulate that by 1.06, and that would be the future value of that $1,000. And then at the end of 3 years, he'll put in $1,000, and that's going to accumulate for 2 years. So to get the future value of that particular $1,000, it needs to accumulate for 2 years. So we're going to raise that to the 2nd power. And then the one that he puts in at the end of the 3rd year, that's going to accumulate for 3 years. So we raise that to the 3rd power. And then the one he puts in at the end of the 1st year, that's going to accumulate for 4 years. So we raise that to the 4th power. And let's make clear that these are dollars. And then we sum all these up, these future values, and then we get the future value of this annuity here. So let's do it the hard way, right? So the first one is $1,000. So let's put $1,000 and store that in the first registry, and then let's take 106 and multiply that times 1,000, and then we're going to store that in the second registry, and then multiply that amount by 106 again, and we're going to store that one in the third registry, and then multiply that by 1.06 again. Then we're going to store that one in the fourth registry, and then multiply that by 10, or multiply that by 1,000. Oh, I'm sorry. Multiply that by 1.06, and then we're going to store that one in the fifth registry. And now let's just add them all up. So recall the first registry plus recall second plus recall third plus recall what's in the fourth registry plus recall what's in the fifth registry, and then we get the amount $5,637.09 here. And so that's the future value of this annuity, right? Now, there are, a few different ways you can compute this. So if we go back and look at the present value of this annuity, we determined that was the $4,212.36. Well, that gave us, if we go back here, that gave us the value at time zero. So that was what that amount here was. Now, if we wanted to figure out what the value of that would be at the end of 5 years, if this amount here was invested in this account at time zero and it was going to earn an effective annual rate of 6%, well, then we would just multiply that by 106 raised to the fifth power, and when we do that, we get the same thing. We get 5,637.09, right? So that's one way of doing it. Now, the other way of doing it is to use the formula that you would use to compute the future value of an ordinary immediate annuity. And that formula is, so future value is going to be equal to 1 plus I, that's the annual periodic effective annual rate, so a periodic effective interest rate, and in this case it's the annual rate because these payments are being received annually, raised to the n, that's the number of payments you have, and you want to subtract 1 from that. Then you're going to divide all that by the periodic effective interest rate. So dropping in the numbers that we have here, so this will be 1.06 raised to the fifth power, and we're going to subtract 1 and divide all of that by 0.06. And if we crank through the numbers, we see we get the same thing, which is $5,637.09. So that's how we can do that using the formula for the future value of an ordinary immediate annuity, and that will yield the answer too. Now you can also do this by using the TVM rule on your financial calculator. So let's look at how that would work. So here, so again, N is 5, 6 is the annual effective rate, so that's IY. The payment is 1,000. So we put that in, and then we're gonna hit compute future value. And we get the same thing, $5,637.09. So that's how you can do that using your TVM roll on your financial calculator, and that's probably the way that you would do it on the exam, because it'll save a lot of time, because again, you're not going to have time to add up these payments. But again, I wanted to start with first principles here so that I can illustrate and explain what is actually going on and why these formulas work and give you the right answer. So if you're ever in a situation where you don't have a TVM roll and you need to compute it, you would know how to do that, right? And so those were the two examples that I wanted to go through just to illustrate how you compute the present value and the future value of an ordinary immediate due, or of an ordinary immediate annuity, right? And ordinary means that the payments are being received at the end of the year. Now, there are a couple key formulas here that I wrote down and that you should basically learn and commit to memory and know how to use them just in case you ever do. So the first one is the present value of an annuity. And so again, that's equal to 1 minus V. And remember, V is just simply 1 upon 1 plus the periodic effective interest rate. And because 1 is being divided by a number that's greater than 1, V is going to fall between 0 and 1. And any number that's between 0 and 1, if you raise it to higher and higher powers, it's going to basically decline in value. And so you subtract V to the n from 1, and then you divide that difference by the periodic effective interest rate, and that would give you something that's called the present value annuity factor, and then you multiply that times the payment, and then that will tell you what the present value of that annuity is. And similarly, if you want to compute the future value of an ordinary annuity, then you take 1 plus the periodic interest rate, and you raise that to the number of payments that you have, and then you subtract 1 from that number, and then you divide that difference by the periodic effective interest rate, and that will give you the future value annuity factor, and then you multiply that future value annuity factor by the amount of the payment, and then that will tell you what the future value of that annuity will be. And again, one of the things you want to make certain that you do is make certain that that periodic effective interest rate matches the payment frequency. So here it's an annual effective interest rate because we're receiving the payments annually or making the payments into the account annually. If we were looking at a mortgage where we would be making the payments monthly, or if we were the bank extending the mortgage where we would be receiving the payments monthly, well then we would want the monthly effective interest rate, and then we would raise, then N would be equal to the number of payments under the mortgage. So if it's a 30-year mortgage, it would be N would be 360. If it was a 20-year mortgage, N would be 240, because that's how many payments you would make with a 20-year mortgage, if you will, right? And so that's pretty much what I wanted to cover here. Now it's important that you really internalize this and understand this, because we'll use these concepts here in corporate finance to come up with the value of bonds. Also, we'll use it to value stock. You will work with something that's called the Gordon growth method, or Gordon growth formula, to come up with the value of a stock that pays dividends that grow. And that's why in the next videos we're going to talk about annuities, where the payments would be geometrically increasing or geometrically decreasing, because you need to know how to value those as well. And so, but this is pretty much what I wanted to cover in this video here. And this is really the basics. So if you can get this down, then all the other stuff that comes after this is going to be pretty easy, and you'll be able to do everything pretty quickly. Because the thing you want to keep in mind is, before you can do these problems quickly on an exam under time pressure, you have to slowly understand what's going on before you'll be able to do it quickly. And so that's why I wanted to take the time and walk you through these steps here. So as always, if you have any questions, feel free to give me a call or leave them in the comment section. And thanks for watching, and don't forget to subscribe to our channel, and also let any other people you know who are studying for the exams know about this resource. Thank you, and best of luck studying.